What are solar panels and wattage they produce? Solar panels are devices that convert sunlight into electricity using photovoltaic PV cells. These cells are made of semiconductor materials, typically silicon, which absorb photons from sunlight and release electrons, generating direct current, DC, electricity. Solar panels are the foundation of any solar power system. Types of solar panels. Monocrystalline solar panel. It features the characteristic uniform black cells with rounded edges, arranged in a grid pattern and framed in a white border. Monocrystalline, high efficiency, typically 18-22%, and wattage ranges from 300 watt to 550 watt per panel. Polycrystalline solar panel. It features the characteristic blue-colored cells with a speckled texture, arranged in a rectangular grid and framed with a white border. Polycrystalline, slightly lower efficiency, 15-18%. Wattage ranges from 250 watt to 400 watt. Thin film solar panel. It features a uniform dark surface without visible individual cells, sleek and lightweight design, often used for flexible or portable applications. Thin film, lightweight, flexible, but less efficient, 10-12%. Wattage ranges from 50 watt to 150 watt. Factors affecting output: sunlight intensity and duration, panel orientation and tilt angle, temperature and shading. Solar panels generate DC electricity, which needs to be managed and converted for household use. The main components connected to solar panels include charge controller, regulates voltage and current from panels to batteries, preventing overcharging. Inverter, converts DC electricity into AC electricity for home appliances. Types of inverters. Monocrystalline inverter, works with monopanels for high efficiency. Hybrid inverter, combines solar and grid power, can manage batteries. Safety devices, circuit breakers, fuses, and surge protectors ensure safe operation. Suppliers of solar equipment can bring different setups. These components are not standard. They come in different sizes and shapes. Latest equipment have different arrangements. What type of batteries are used? Batteries store energy for use when sunlight is unavailable. Common types include lead-acid batteries. Cost: affordable and widely used in automotive and backup power applications. Weight: heavy compared to modern alternatives. Maintenance requires regular topping up of electrolyte and cleaning terminals. Durability: moderate lifespan, 3 to 5 years if properly maintained. Sensitive to deep discharge cycles. Efficiency: lower energy efficiency, 70-80%, due to energy loss during charging and discharging. Best use: short-term backup power, starter batteries, and low-cost systems. Lithium-ion batteries cost: more expensive upfront but cost-effective over time due to longevity. Weight: lightweight and compact, ideal for portable devices and EVs. Maintenance: virtually maintenance-free. Durability: long lifespan, 8 to 15 years, with thousands of charge cycles, handles deep discharges well. Efficiency: high energy efficiency, 90-95%, with minimal energy loss. Best use: renewable energy storage, electric vehicles, and high-performance electronics. Gel and AGM batteries, advanced lead-acid variants. Cost: more expensive than standard lead-acid but cheaper than lithium-ion. Weight: still relatively heavy. Maintenance: maintenance-free design, sealed to prevent leaks. Durability: better than traditional lead-acid, 5 to 7 years. Resistant to vibration and temperature extremes. Efficiency: slightly higher than flooded lead-acid, 80-85%, but still less than lithium-ion. Best use: off-grid solar systems, marine applications, and environments where maintenance is difficult. What type of batteries are used? Batteries store energy for use when sunlight is unavailable. Common types include lead-acid batteries, affordable, widely used, but heavy and require maintenance. Lithium-ion batteries, lightweight, high efficiency, longer lifespan, but more expensive. Gel and AGM batteries, variants of lead acid with better performance and less maintenance. Battery sizing depends on daily energy consumption and desired backup duration. How kVA is calculated for different appliances. You will have seen solar dealers advertising their packages. This is what they often display: 1 kVA, 3 kVA, 5 kVA, and so on. kVA means kilovolt ampere. This is the power output produced by the solar system that will have been installed. The reason why we go for higher kVA output is obviously to be able to power our home appliances. But I can tell you today that it's more to do about the appliances you use than just getting the higher output solar system. Okay, let us dive into how these calculations work. Appliance power consumption. Every appliance has its own power consumption. Not all appliances are designed to be used on solar panels. The secret, which you are not told by solar panel providers, is the power factor concept, which of course I don't blame them because of technical complexity of the concept. I simplify it for you. The power factor is a number that specifies the power efficiency of any appliance. If your household power factor is close to 1, then it means you are using the most efficient appliances. For example, if your power factor is 0.2, your appliances are less efficient. Some microwaves have a power factor between 0.9, 0.95, which is very efficient. The power it requires from your solar system is calculated as its wattage, usually displayed on the appliance, divided by the power factor. So this would be, say, 1000 watt, which is 1 kilowatt divided by the power factor, 0.95. This gives you the power which your microwave draws from the system, which is 1.05 kVA. Here is how each appliance draws power from your system. If you choose, say, 1050 watt LED lights, which have a power factor of 0.9, they need 0.56 kVA. A 150 watt TV with power factor 0.95 requires 0.6 kVA. A 200 watt fridge with power factor 0.8 needs 0.25 kVA. A 1000 watt microwave with power factor 0.95 requires 1.05 kVA. A 1500 watt borehole pump with power factor of 0.75 requires 2 kVA. All these have a total of 4.02 kVA. That is why for this combination of appliances, a 5 kVA is recommended. Let us now look at what we can do to reduce the power demand for our appliances. There are 2 ways. 1. Use low wattage appliances such as LED lights, 100, 150 watt TVs, 100, 400 watt fridges, 300, 500 watt microwaves, less than 1500 watt borehole pump, but this will depend on your head requirement. If you need to draw water from a deeper borehole, this might need more power. 10 LED lights, you need 0.56 kVA, approximately 1 kVA. This will accommodate small things like charging phones and laptops. You can include a TV, but it has to be a lower wattage and high power factor, but it's safe to have slightly more than 1 kVA. If you include a low wattage fridge, the demand is still under 1 kVA. Having 1.5 kVA is advisable. If you include a microwave, the demand rises to 2.02 kVA. If you choose a 400 watt microwave, the power demand will only be 1.39 kVA. If you include a 1500 watt borehole pump, the demand is only 3.39 kVA, which is approximately 4 kVA. How do we choose high efficient appliances? Appliances are labeled with specification details. Look out for lower wattage appliances depending on what you want to use them for. Also check if the power factor is included. Usually it should be a higher one, close to 1. If the power factor is, say, 0.3, the appliance is inefficient. Usually an energy efficiency label is found on most appliances. The colors from green to red mean more efficient to less efficient. For example, this label shown here is most efficient at A, with a wattage of 123 kilowatt hour. For your solar appliances, choose the one with labels indicated with that black arrow at AD. When buying power tools such as drills, grinders, and so on, use battery powered to avoid overloading your solar system. Final advice on buying appliances suitable for solar systems. When selecting appliances for a solar-powered home, consider the following. Choose energy-efficient appliances with high power factor greater than 0.9. Opt for inverter-based fridges and air conditioners for better performance. Use LED lighting instead of fluorescent or incandescent bulbs. Avoid oversized motors. Select pumps and machines that match your actual needs. Check appliance labels for wattage and PF before purchase. With these guidelines, you can maximize the efficiency of your solar system and reduce costs. Thank you for watching. Like, share, and subscribe.